Morning everyone. Today we are going to discuss in our senior inter first first unit is waves, which is having that 8 marks of weightage, one long answer question which comes in the public examination and for the 8 marks. So first of all, what is wave? Wave means which a wave a disturbance that propagates without transport of matter, means there is a matter whenever some of the disturbance is happened in the matter, that the energy is propagating from one point to the another point, from one point to the another point through the matter, but the matter cannot move from the initial position, only it vibrates at the initial position. Then always do not require medium, because of some, if we consider a light waves which is traveling from the sun to the earth, the sun rays which do not require any material medium, because of between the sun and earth there is some vacuum place is also there. Due to that vacuum place, without any medium also sun rays are passing to the earth. So that's why all waves do not require any material medium. And the classification of waves means the waves can be classified into the generally the 4 types of waves. That is, first one is mechanical waves. Mechanical waves means with the waves which require material medium to propagate from one point to the another point or one place to the another place, they require material medium. Like for example, sound waves. For example, wherever we are speaking something, to reach the other point, there is some material needed. So that's why we can say that mechanical waves require material medium to propagate the sound waves or seismic waves or water waves. We can tell the examples for the mechanical waves. Next one is electromagnetic waves. Earlier we have told that the sun rays are passing from the sun to the earth without any require of material medium. Like that, electromagnetic waves is nothing but sun rays. They do not require any material medium, and they consist of oscillating the electric and magnetic fields. Electric and magnetic fields. The electromagnetic waves consisting that the electric and oscillating electric and magnetic fields. So they do not require any material medium like the visible light, radio waves, microwaves, gamma rays, X-rays, etc. They can move with the speed of a light, which is equal to c is equal to 3 into 10 to the power of 8 meter per second. Means the X-rays, Y-rays, gamma rays, and at the same time radio waves, microwaves, those are all waves will move with the velocity of light, equal to the velocity of light. Then the third one is matter waves. Matter waves means these are associated with the constant particles, means like electrons, protons, neutrons, like that. The matter waves consist of associated with the constituent particles, the matter which is containing that electrons, protons, neutrons, like that, they constituent particles. The matter like electrons, protons, neutrons. And the other one is gravitational waves, suggested that cosmic bodies. Cosmic bodies means cosmic bodies like produce these waves interacted with each other. Means gravitational earth feel that gravitational force to interact with the two bodies. They attract with the two bodies. So in the galaxies also, stars and at the same time planets, these are having they can produce the gravitational waves to interact to each other. So that's why we can say that suggested that the cosmic bodies produce these waves, means gravitational waves, and interact with each other through these waves. These are the classification of types of mechanical waves. In types of mechanical waves, there are 2 types of mechanical waves. Is there? The first one is longitudinal waves. The first one is longitudinal waves. What is meant by the longitudinal wave? Longitudinal wave means the direction of the propagation of vibrating particles which is in the medium from its mean position, is parallel to the direction of the propagation of a wave is known as longitudinal wave. Means when if we take the spring and we expanded that thing and release, then it will start oscillating vertically. Means the direction is the wave is in this direction, and as well as the vibrating particles means which is having the constant particles by the spring is also moving in the parallel to the direction of the wave. So that's why we can say that the direction of propagation of a vibrating particles is from their mean position is parallel to the direction of a propagation of a wave is called a longitudinal wave. It's called a longitudinal wave. Once again, the direction of the propagation of the wave whenever the spring is expanded by using the force and released, then the spring starts oscillations, means either vertical or horizontal. It doesn't mean that whenever they start oscillations means it is in simple harmonic motion, then they expanded and compressed. So that's why we can say that whenever the direction of the propagation of the vibrating particles is parallel to the direction of the propagation of a wave is called a longitudinal wave. For the example, sound waves are the best example for the longitudinal waves. Sound waves are the example for the longitudinal waves. We can say that in this longitudinal wave, compressions and rate fractions will be formed. Compressions and rate fractions will be formed in the longitudinal waves. What is compressions and what is rate fractions means? If the distance between the two consecutive particles of the medium is more than the normal distance, means the normal distance of the spring will be less than if we whenever we expanded that one, the distance will be increases. So that's why if the distance between the two consecutive particles, if the distance between the two consecutive particles is more than the normal distance, is called rate fractions. And if the distance between the two consecutive particles is less than the normal distance is called as the compressions. Once again, if the distance between the two consecutive particles of the medium is more than the normal distance are called rate fractions. And if the distance between the two consecutive particles is less than the normal distance is called as compressions. In the longitudinal waves, the compressions and rate fractions will be formed. If the distance is less than the normal distance is compressions. That means say if the spring is compressed. So that's why actual distance is decreases. The normal distance less than the normal distance. So that's why that is called as compressions. Whenever the consecutive particle nearer to one another. If the rate fractions means the particles are away from the one another for the more than the normal direction. If we are not using any force on the spring, then that will stay at the normal distance. If we use the force to expand, the normal distance will be increases. And if the oscillations, whenever the medium is in simple harmonic motion, the spring is in simple harmonic motion, then that will start oscillating, the compressions and rate fractions will be formed. So that's why we can say that in longitudinal waves, compressions and rate fractions will be formed. Once again, what is the longitudinal waves means? The direction of the propagation of a vibrating particle from its mean position is parallel to the direction of the propagation of a wave is known as longitudinal waves. In longitudinal waves, compressions and rate fractions will be formed. Compressions and rate fractions will be formed. Compressions and rate fractions will be formed. Rate fractions formed. Compressions means the distance between the two consecutive particles is less than the normal distance is called as compression. If the distance between the two consecutive particles of the medium is more than the normal distance is called rarefaction. So this is about longitudinal waves. The best example for the longitudinal waves is sound waves are the best example for that. The second one is transverse waves. Transverse waves means the direction of the propagation of vibrating particle from its mean position is perpendicular to the direction of propagation of wave is known as transverse wave. Once again, the direction of propagation of the vibrating particles from its mean position is perpendicular to the direction of the propagation of a wave is called a transverse wave. Here, in the transverse waves, crusts and troughs will be formed. Crusts and troughs will be formed. So, here is that what is crust? What is crust means? First of all, in transverse waves, the direction of the propagation of the wave is in this direction. The direction of the propagation of wave is in this direction, and the direction of the vibrating particles means in like water waves. We can see the oceans. The waves are coming to the bank. So here the waves whenever they are coming to the bank, they will move like this in a wave formation. In that the vibrating particles are moving perpendicular, means the vibrating particles are from its mean position, they are moving perpendicular to the direction of the propagation of the wave. So that's why we can say that the direction of the propagation of the vibrating particles is perpendicular. The direction of the propagation of the vibrating particles is perpendicular to the direction of the propagation of the wave is called a transverse wave. The best example for the transverse wave is water waves. So in that the transverse waves, the crusts and troughs will be formed. Crusts and troughs will be, what is crust and what is troughs? Here the crust means the maximum displacement of the vibrating particles from the mean position in the direction, in the positive direction. In the positive direction means here it is that this is the positive direction and this is the negative direction. So that's why if the waves are the vibrating particle from its mean position, if they move into the positive direction, that will be the crust, that means the crust. And if in case the vibrating particles are maximum displacement from its mean position towards the negative direction, in the negative direction, the maximum displacement, the negative direction is called a trough. And at the same time, in this crusts and trough will form whenever the distance between the two consecutive successive crusts and two successive troughs or two consecutive successive crust and trough is called a wavelength.